So if both versions match, it's okay. I have nothing to do. But if the versions aren't the same, then I will update my Helm release to match the versions that my Helm release object has told it to run. Once that's done, I can update the Helm release statute with any information that I want. So in my current custom resource, I'm updating the Helm statute and the description of the release. But any other information that you would want to store in this statute, you can use this method to store it. At any point of time during this method, if there is an error happening, you can re-enqueue the event so that it's processed again later. And this is really the declarative design being shown here, because every time you can't match the states, you will return an error and it will always try to match the desired state until it eventually does. If no error has happened, you reach that piece of code whereby a successful sync event is returned and the controller knows that the desired state has been reached. There are other benefits to using custom controllers and CRDs. You can implement them using your choice of programming language. So I've used a sample controller from Kubernetes, which is in Golang, but you don't have to use Golang. If you look on GitHub, you will see custom controllers in many languages like Python, Java, Bash, and I've even seen one in Elixir, if you fancy some functional programming. It can enforce validation. So I've shown earlier that I check whether my custom object has a release name and a release version. And for the purpose of this demonstration, it's fine. But there are more efficient ways that you could do that, whereby you enforce your CRD itself, your custom resource itself, for non-empty values for those two parameters. And the advantage of this is that if you have a validation on the kind of fields that you expect and the values that they can have, if you try to create an illegal custom resource, the Kubernetes API will refuse to create it because it's missing some parameters or it's using some illegal ones. Custom resources can support status and scale sub-resources, and maybe in the future they will be able to support exec and log. And again, all of those would be running, they would be running a logic of your own once you implemented that within your own custom controller. So the key takeaways from here is why we need Helm release automation. I've made a brief comparison of using custom controllers versus using the Flux Helm operator. I've given an overview of custom resources and custom controllers, and I've given an example of Helm release controller and how it works. So I'm going to go on about Helm operators, but I'm not going to talk about them a lot for the reasons that I've said earlier. There has been other talks about it in this conference, which I think can talk about it with more expertise than I would be able to. So the Flux Helm operator is an extension to WeFlux. It's essentially a custom controller built by Flux. However, the limit between a custom controller and an operator is not a very, it's very flexible. It's open source, it's already production ready, and since July of last year, it handles rollback of failed Helm releases. So if you're interested into using the Flux Helm operator or learning a bit more about how it works, I invite you to attend this workshop on GitOps continuous delivery with Helm operator tomorrow. And there were also 2 talks earlier today from WeWorks themselves, which I think will be posted on YouTube later. And another talk from Yosuke Kukoa on shipping your Helm charts using GitOps. So last but not least, the work presented in this conference is not only my work, but also the work of all of my team. So I would like to thank them for allowing me to speak on their behalf today. Thank you. Let me see if I have finally, yes, so. Right here, I've applied a change to my resource where I just said that I want to have the blue unicorn instead. So when I do kubectl get pods, you see the pink unicorns being terminated and the blue unicorn starting. And if I describe my Helm release object right now, I can see that it's running the blue unicorn and the content of the statue is updated. That's it. Yes? Yeah? Yeah. I think so, but that was in April and I can't remember what I've done. So I think it's watching all the namespaces. Yes?
So, your custom controller approach, how do you plan to support values?
The current one that I've built, it was done in one afternoon only as a proof of concept. So right now it doesn't, but the end game for it would be to have the values passed within the custom resource itself so that we can read them from here. Yes?
I'm wondering from many examples of CRDs, maybe you could just put it into a config tab and just start some deployment.
So CRDs, when you use them without any custom controllers, they are essentially config map. But when you use them with a custom controller, the custom controller will look at a type of object. So it can't look at a custom object like Helm release, or it can look at config maps. But then it will be looking at all the config maps, so you could still filter on the name of a specific config map, but it wouldn't be faster than watching a single type of event just for that.
Okay, so it's basically the one-to-many relationship that you have.
Yes, yeah.
Okay.
Cool.